Our next finalist is Abigail Fry, and the title of her presentation is Uncovering the Unknown, Identifying Drug-Resistant Tuberculosis.
Imagine this. A quarter of all humans have a deadly pathogen inside of them, waiting to strike. Every year, 10 million people will fall ill. 1 million of those people will die. This is not the plot of a science fiction novel. This is the reality of the deadliest infectious disease in the world, tuberculosis. We don't hear much about tuberculosis or TB here in the US, but essentially it is a bacterial infection of the lungs that spreads person to person through the air, and it can be treated. 1 in 25 cases of TB is drug resistant, meaning that the standard treatment regimen will not work. Now, the good news is many forms of drug-resistant TB can be treated with alternative antibiotics if they are properly diagnosed. The most efficient way to perform this diagnosis is by screening the DNA of the bacteria for drug resistance mutations. But the bad news is we don't know all of the mutations to look for. In my research, I am working to identify these unknown mutations. To do this, I use a mix of computational and lab-based techniques. In the computational work, I analyze big data sets of DNA sequences from bacteria from patients around the world. And with this approach, I identified a new gene that, when mutated, is associated with an increased rate of treatment failure. But the only way to know for sure whether these mutations cause drug resistance is in the lab. Here, I work with the actual pathogen, genetically engineering it to have the mutations I identified in the patient samples. Then, I test the mutated bacteria's ability to grow in the presence of antibiotics. And I found that these mutations do cause drug resistance, in fact, to multiple of the antibiotics in the standard treatment regimen. Plus, by further studying these bacteria in the lab, I identified the ways in which the mutations weaken the bacteria. Together, this data can inform doctors on what antibiotics will be most effective against this type of infection, hopefully improving patient outcomes. So now imagine a world in which no one dies from drug-resistant tuberculosis. I hope that by identifying the drug resistance mutations we've been missing, we are getting a little bit closer to making that our new reality. Thank you.